Hello! Okay, so solving polynomial equations graphically. We're only expected to solve these with our graphing calculator, which is of the TI family. Generally, you can also, there are other approved calculators, but you know, if you're planning on switching or changing to some zooty new calculator, make sure you check and see if it's on the approved list, okay? Because otherwise you may not use it on your diploma exam, and you don't want to have that, right? So you want to be working with the calculator that you're planning on having for the rest of your high school, right? So that when you walk into that diploma exam, everything is good. Okay, so we're going to solve graphically. We got a couple of methods we're going to look at. So method one is the intersection method. So if we have an equation that looks like this, 2x squared plus 8x plus 1, 2x squared plus 8x plus 1 is equal to 3x plus 4. Then here's what we do. Okay, we get out our calculator. We turn it on. We go to y equals. And in y1, we're going to put the left side of the equation. Okay, so we're going to put 2x squared plus 8x plus 1. And we're going to hit enter or down arrow. And in y2, we're going to put the second equation, 3x plus 4. Okay, so in this one, we've graphed y1 is equal to 2x squared plus 8x plus 1. y2 is equal to 3x plus 4. And we're now going to go look at the graph. On a graph. So every time I start this calculator, it's basically reset. Okay, so your window should be the standard window. In this case, the standard window is fine, right? We can see everything we need to see, which is I can see the parabola, I can see the straight line, and I can see the intersections here and here. Okay. What we want to do is we want to find the value of x that makes this true. Okay, so what value of x will make this true? So we go second trace, or second calc. Number 5 is intersect. Okay, now here's how I do intersect. It's going to ask you for 3 things. It's going to ask you for the first curve, and that, notice it's here. Then it's going to ask you for the second curve, because you might have more than 2 curves, right? Generally we don't do that, but you might have more than 2. It's going to ask you for the second curve, then it's going to ask you for a guess, which is like about where do they intersect. So what I do to make things a little more efficient is I'm going to trace along the curve until I'm at the intersection that I want to find pretty much, right? Okay, there. So I'm pretty close to the intersection, right? So it's asking for the first curve. I just hit enter. It will then jump to the second curve. Okay, again, if you've only got 2, it then jumps to the second curve, and I hit enter because it's on the second curve, and then it asks for a guess. And because I moved to about where they are, I just hit enter again. And it gives me the intersection is at -3, -5, right? So the solution is the value of x that makes that true. Okay? So the solution is -3. So the point of intersection is -3, -5. Right? The solution to this equation is that x is equal to -3. Right? If x equals -3, this is true. If x equals whatever that x value is, this is true. If x is any other value, like 0, this is not true. If x is 0, this says 1 equals 4. Not a true statement, right? So what we're looking for is the value of x that makes this statement true. Then that will solve the equation. Okay, so let's just sketch what we have there. Well, I don't need to do that really, right? Because, I mean, it's there, you can see it. Okay, doesn't need to be in the note. Well, okay, yeah, let's sketch it, because if I just save the notes as a PDF, then it won't be there. What does it look like? And when you're drawing sketches, you are, of course, going to put arrows on, right? Okay, so calculator doesn't, but you do. And so we know now that the coordinates of this point are -3, -5. Okay, but there's one more point of intersection, So second calc, intersect. Now, what's the fastest way to get from here to here? Is it going around the curve or on the straight line?
Around the curve.
Okay, so if we want to go, just to show you something a little bit different, right? When it's asking for the first curve, if I hit the down arrow, it's just going to, if I actually hit the down arrow.
You can't do it.
If I hit the down arrow, it's going to change curves, right? So y1, y2, back to y1 to y2, or if I hit the up arrow, right? It's just going through the list of things that it has in y equals, ignoring any blanks, right? Like y3, 4, 5, 6, 7, 8. Okay, so I'd say, hey, it'll be faster to get there if I just trace along the straight line. Stop. Okay, so I'm there, I'm pretty close. Now the first curve this time will become y2. Doesn't matter, right? Because here's how I do intersects, right? You go second calc, number 5 is intersect. You move the cursor until it's at the point of intersection. You hit enter 3 times. 1, 2, 3, and it solves. 0.5, 5.5. Okay, I'm going to assume you all have this sitting in your calculator, right? You're looking at the very similar looking display. 0.5, 5.5. Okay, so we state the solution, which is that x is equal to -3, or x is equal to 0.5. Okay, and that is the solution to this polynomial equation. Okay, so in method 2, we're looking at the zeros method. Actually, you know what? Let me do this on a separate sheet. Okay, so our original equation was 2x squared plus 8x plus 1 is equal to 3x plus 4, right? We're going to rearrange that equation so that the right side is 0, right? In other words, we're going to move everything to the left side. And we do that by subtracting 3x from both sides. So it'll be 2x squared plus 5x. And we're going to subtract 4 from both sides, giving me -3. And that is equal to 0. And now what we're going to do is we're going to graph y1 is equal to 2x squared plus 5x minus 3. And I'm going to show you 2 ways to solve this. The hard way and then the easy way. At least the way I like doing it. Okay, so first thing I'm doing, I'm just going to go back. I'm going to clear out anything that's in my y equals, right? Which is a good thing to do when you move to another question. Just go clear out everything that you've put into y equals. Okay, in y1, we're going to enter 2x squared plus 5x minus 3. Now that's all we have to graph, so we're going to now hit graph. And we want to find the zeros, right? We want to find what values of x make this equal to 0. Fancy word for that is the x-intercepts, right? The values of that, how do you find the x-intercepts? You set y to 0, okay? Y is 0, we're going to find the x-intercepts. So the graph we're looking at now looks like this. So how do you do zeros? Here's the hard way. You go second calc, and number 2 is 0. The 0 asks for 3 things. It asks for a left bound. So what I need to do is move the cursor until it's to the left of the 0. And I hit enter. Then it asks for a right bound. Now I'm going to make a little mistake here just to show you. I'm not going to go, so I'm going to hit enter here, and it asks for a guess, and I'm going to move to about where the 0 is and hit enter. And it says boundary, right? Like you didn't give me a good enough bound, right? So try again. Second calc 0. So let's say I do this as the left bound and this as the right bound, and I move back and say there's my 0. Oh, still boundary. So you need to be above and below. Okay, so yeah, second calc. Let's do it right this time. Left bound, good enough. Right bound, good enough. Guess. Closer. There we go. 0 is at -3, right? So 0 is -3, 0. Okay, so what are we looking at? We got a graph. It looks like that though. get a graph. Looks like this. This is the point, negative 3, 0. That's another point. Okay, so we go back, second calc, number 2, 0. Left bound, this time it's going to be below, right? Because the left boundary, I want to be to the left. I'm going from left to right, so I need to be below, so I'm going to choose there. And above, there, and go. And we get the zeros at 0.5 comma 0. You know, shocking, I know, but we could never have guessed the solution would be exactly the same. Okay, that's the hard way to me of doing zeros. Here's the easy way. I like to do zeros by doing an intersect. So what I like to do is go to y equals, and I set y2 equal to 0. Now, all that's going to do is graph the x-axis, right? So you're not going to see it. But there actually is now a curve on here. And now that I have two curves, I can do an intersect. So I go second calc, number 5 is intersect, and all I do is move about to the point, and I don't have to worry about left bound, right bound, right? I just hit enter 3 times because I'm doing an intersection. So you note the first curve, 2x squared plus 5x minus 3. The second curve, y2 equals 0, and my guess, which I'm about there, and hit enter, and there's the intersection, right?
I don't recommend going on the calculator. Yeah.
Okay, so it's okay to erase this. Okay, and we want to do the other one, so we go second calc, again, intersect. So I prefer intersect to 0 just because I don't have to worry about left bound, right bound. I'm close, I'm not that close really, but you hit enter again. So now it's going to jump up, right? It's just going to go on whatever value of x it was, it's just going to move up to the y, and then yes, and 0.5. Okay? As long as you're reasonably close, it's going to give you the answer. So, okay, so 2 methods and then 2 sub-methods within method 2. Method 1 is the left side of the equation goes in as y1, the right side goes in as y2, and we look for intersections. Method 2 is rearrange the equation so that it's set equal to 0 and then find the zeros. Right? And in this one, I prefer to do y2 equals 0 and then do an intersection. Okay, as opposed to now, you know, sometimes you get numbers like you know, negative 1.3 e negative 14 or something. That's really 0, right? The e means times 10 to the power of. That's your calculator's way of saying times 10 to the power of. So it's giving you like a really small value for the x, you know, because it says, well, I found a value. You know, it's like 1.2 times 10 to the negative 13. Well, that's 0.0000000. You know, so in effect, it's 0. Okay, so you may have to read that into the value that your calculator gives you. Okay, oh, I haven't fired that up yet. If we try this in Desmos,
it will not tell you the intersect online.
we'll do the, wait, so in Desmos, I actually do have it set to show the intersection. So you see it's showing points of interest, like the x-intercept of this graph. Oh, it's not showing the x-intercept of the graph. The y-intercept of this graph, the intersection between the two. Okay, so if I click on them, and somewhere that option is up here somewhere, I think.
No, you just click on the other red line.
Okay, and then we can get these 2 points as well. Apparently can't move that, but I guess I can turn it off. You know, nice thing. I mean, here these are pretty exact values, right? Negative 3 is exact, 0.5 is exact. These are not exact values if you're actually finding the x-intercept. You would have to express it as a radical, right, to get the exact value. Hey, you made it just in time for the end of the class because we're